Hello and welcome to another video. This time I'm going through a paper which is new to me. It's called the Aero EEE. It's the maths aptitude test basically for Imperial College Aeronautical Engineering or Electrical Engineering. I've never met this paper before this year, and funnily enough they've just changed the sample papers, I swear, this week, because I was working out solutions for a different sample paper just 3 days ago, and now I've realised they've changed it. I've got to do the whole video again. Anyway, before I go further, my YouTube channel is moving. This is my new YouTube channel. This is where I'm going to be putting all my solutions up. It's also where I'm going to be putting the next two parts of this video up. So I'm doing questions 1 to 10 here for the Aero mat, but I'm going to do 11 to 20 and 21 to 30 on my new YouTube channel. So that's that one. So please do join it. You can see it's not this one, like I've changed basically. This is something called Peterson's graph, my symbol, my logo if you like. Well, that's pentagram. If you're on that, that's the channel basically which I won't be uploading on anymore. The reason I'm moving is just that I'm not going to have control of this account for much longer, so I've kind of got to. So move to this one. This is still Peterson's graph, but just a rearrangement of Peterson's graph. Okay, let's get on with some questions then. So I'm just going to do questions 1 to 10 here in this video. And 30 minutes is all you get for this paper. 30 questions, 30 minutes. Wow, it's hard to do in 30 minutes. Very hard. I would say nigh on impossible for humble people like myself anyway. Okay, so log base e of 1, well, that's 0, isn't it? Log base anything of 1 is 0 because e to the 0 equals 1. And so this is 0 equals sine x, whereas sine x 0 at pi, yeah? So first question was a settler question, I would say. Okay, next one is not too bad either. 8 factorial is 8 times 7 times 6, and as you can see I'm writing them down in their prime factor decompositions, times 5 times 4 times 3 times 2, yeah? That just makes it easier for us to think about. And so when we're doing this, we can use log laws and say, well, that's the same as log. I won't bother writing down base 10 because then you know it's in base 10. Now, clearly I've collected all the 2's together, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, 2 to the 7. So you could have 2 to the 7, which is 7 log 2, plus log, and then you've got to account for what we've done. The 2's, give them a tick. You need 3's, and there's 2 3's, so that's 3 squared. That's the 3's dealt with. And then you've got 7 and 5. Well, that's log, 7 times 5 is 35, so that's log 35. From that, I can just see it's going to be A. Yeah? Okay, right, that's good. So number 3, solve these simultaneous equations. Now, always look at what you've got. Don't just look at the first one. Look at this one, yeah? Only one letter in it. We can definitely solve it then. So that's ln of 2z equals 0. So 2z equals e to the 0, which is 1. So z is a half, yeah? Oh, how did that happen? Where's my... Oh, connection restored. So z is a half. Straight away I thought, well, it ain't A or B. If I'm in a rush and I need to guess, at least I've got it down as a 50-50. But I don't need to guess because just plug it into 3. You've got 8y minus 10 equals 6. So y is going to be 16. 2 times 8 is 16, so y is 2. So I straight away just thought, well, I won't go any further. I'll just go for that because you're really up against the clock in these questions. Okay, this one, I hope you can see immediately. It's a disguised quadratic. Let u equal ln x. Did I write my answer down? Yeah, so you've got CAC so far. Okay, so if we've got that, then you've got u squared. Now this is going to become minus 2 ln x, which is minus 2u. Minus 63 is 0. So u minus 9u plus 7 is 0. And so it looks like ln x equals 9, or ln x equals minus 7. Now, if you now undo that, you can have x equals e to the power of 9. I'm just glancing down at my notes here. Yeah, absolutely. So ln x equals e to the power of 9, or x equals e to the minus 7. They've started putting this none of the above in it, and it is sometimes the answer. Sorry, because I scanned these 3 answers. I didn't look at the next one. I thought, have I done it wrong? No, it is none of the above. So watch out for the none of the aboves. I know quite often in the math challenge, if it says things like more information is needed, it's almost never that answer. But this is not the case on this paper, so be careful. Okay, number 5. What is x cubed coefficient in a series expansion of this? Okay, this just requires a bit of care. I firstly just wrote down the second bit, the second bracket, because I thought I can expand that in my head to x to the 6 plus 3x to the 4 plus 3x squared plus 1. You know, it's just the next row down of Pascal's triangle after 1, 2, 1. So you've got 1, 3, 3, 1. And the 1 plus x cubed is just, you know, x cubed plus 3x squared plus 3x plus 1. And so we're just squaring those x's. Okay, and then I thought, well, how am I going to get an x cubed from this? Well, it's going to be, I can ignore these two terms. It's just going to be this term and this term, which are going to give it to me. So I need the x cubed term here to times it by 1. Now, I'd find, you know, if I'm just looking at this bracket now, yeah, for x cubed, yeah, how are we going to get that? Well, you're going to have minus a half to the power of 4. You're going to have x cubed, and then you're going to have a 7 choose 4, 7 choose 3, whatever you prefer, yeah? Now, that's simply going to be 1/16 times by, and now 7 choose 4. Now, that's like 7 times 6 times 5 over 3 times 2 times 1, isn't it? So cross those 6's out, you can see it's 35. Okay, so we've got 35 over 16, yeah? Now, the other way we're going to get it is the x term, which times is by the 3x squared. So if I can just write that out, x. Now, how are you going to get an x? You're going to go minus a half to the power of 6 times by x times by 7 choose 1, which is just 7. So we've got 1 over 64 times 7. That's going to be 7 over 64. But don't forget, we're timesing it by 3x squared, so we're going to end up with 21 x cubed, sorry, over 64. Yeah? Now it's just a case of combining these. That is obviously 140 over 64 x cubed. Add them together, you can see it's A, I think. I'm just checking my notes. Yep, I've got that one right. Good. Okay, number 6. I just looked at this. What is the area of ABC? And I thought, that's a weird question, because surely you can just find the area of ABC. I could basically ignore the waffle at the start because I thought the diagram's great, it's showing me everything. If I want to find the area of ABC, then I'm going to find the area of the big triangle, yeah, and take away from it the area of the little triangle. That's what I'm going to do. So, okay, the area equals, okay, the big triangle has base 5, perpendicular height 2. So it's a half times 5 times 2. Minus, now the little triangle has base 5, perpendicular height 1. And so we've got 5 minus 2.5, and so the answer is 2.5. And so the answer is A, I think, for that one. Yeah. Okay, number 7. Right, this used to be in further maths, length of a curve, but they took it out. What a shame. Okay, so we've got to basically use this as our y equals ln sec x, and I'm going to differentiate it because I seem to need dy by dx and square it. Now, if you differentiate sec x, you get sec x tan x. You want to know these because there's no formula book in this exam. Multiplied by, I'm doing chain rule here, I've differentiated within the function. Now I'm going to differentiate ln of stuff. Well, that is 1 over the stuff. And so that actually does differentiate to tan x, yeah? And you might just know that tan x integrates to ln sec x, and so you knew this straight away. Good. I actually worked it out, I forgot. Okay, so what have we got here? We've got between b and a. Oh, but no, pi over 4 and 0, because they want us to do it on this interval. We've got the square root of, okay, 1 plus tan squared, but that's sec squared. So we've got, you know, we're just going to be integrating sec squared square rooted. Now, you know, they told us that ln sec x plus tan x differentiates to sec x. So in other words, they've given us the integral for sec x. That's going to be ln sec x plus tan x between pi over 4 and 0. And so what are you going to have there? You're going to have ln of, okay, cos of pi over 4 is 1 over root 2, so sec of pi over 4 is just root 2. Tan of pi over 4 is 1. Minus, and then cos of 0 is 1, and so sec of 0 is 1, plus, and so you just get ln 1, but that's equal to 0, and so the answer is B, yeah? Oh, and I should have put these in a modulus as well, that's true, but, well, actually, no, I shouldn't. Why, what would be the need to? Root 2 plus 1 is positive, so that seems unnecessary. So, yeah, that answer is going to be B, I think. Okay, what are we on now? Number 8. What is the coefficient of the x squared term in the expansion of the following? This is a little bit fiddly, really, to be honest. And look, they've given you the formula for it, which is kind. So first thing I did was I looked at 1 plus x to the minus a half, and that equals 1 plus n times by x plus n times n minus 1 times by x squared over 2 factorial, yeah? And so then I simplified that, 1 minus x over 2 plus, that's going to be 3/4 divided by 2, 3/8 x squared. Yeah, and then I just multiplied it by 2x minus 1, and I didn't need to multiply it all by 2x minus 1 because which term is it? I want the x squared term. I only had to think about the terms which multiply to give x squared. Now that's this one and this one, and this one and this one. So maybe I'm misremembering this and it wasn't as bad as I thought. So I've got x squared minus, now let me just check that I haven't made sign errors here, because you know what it's like, it's really easy to make a sign error. This looks all right to me, it looks all good. Okay, brilliant. Oh, yeah, okay. The reason I'm misremembering this is because I originally, when I did this question, wrote this as 1 minus 2x and then ended up with a negative of the answer. And that confused me. Okay, so what do we got here? We've got an x squared and we've got a minus 3/8 x squared. Yeah, let me just check some of my working here. Yeah, no, that looks good. Cool, that's minus 3. Yeah, oh yeah, look, it's a minus x squared, minus 3/8 x squared. Easy to blunder on these, isn't it? And that gives you minus 11/8 x squared. Yeah, so it's B. Cool. I missed that minus sign there. Look, it's your own handwriting often which can let you down in maths questions. Mine does. It's, you know, I know loads of people I've taught over the years as well who've been really, really good at maths but scrappy with their handwriting, and they do make blunders because they miss their own handwriting. So watch out. Okay, which of the statements are true about this? Well, concave downwards and concave upwards. Well, let's talk about concave downwards and concave upwards. That's concave downwards, or just concave. This is concave upwards. I thought it was a lovely little wiki article on this where they give about 10 different ways of saying concave. Like they talk about concave downwards, negative convex, and you just think, oh my god, just keep it simple. But that's concave downwards, that's concave upwards, yeah? So we need to know that in this question. We just want to differentiate it. If we're thinking about the points of inflection, differentiate it, you get 6x squared minus 16x minus 2. Differentiate it again, yeah? Because whilst the second derivative being 0 isn't a sufficient condition to show that something is a point of inflection, because it could still be a minimum or a maximum, it is a necessary condition, yeah? So we have to have a second derivative as 0. So we're going to have 12x minus 16. Solve that. And you can see what you might describe as a suspected point of inflection at 4/3. And actually, if you solve this equals to 0, yeah, if you were to solve that, 0 equals 3x squared minus 8x minus 1, and use something like the quad formula, you're going to end up with a minus b plus or minus root of b squared minus 4ac over 2a, yeah? You're going to end up with 4/3 plus or minus some value, yeah? That's because basically the turning points on a cubic exactly slap bang in the middle of them. You've always got a point of inflection, yeah? That's a true story, that is, yeah? You've always got a point of inflection slap bang in the middle of two turning points. It's not a stationary point of inflection, it's a non-stationary point of inflection. And so, you know, here is your point of inflection. Now, I could, you know, this seems on the face of it probably true, yeah? But look at the statements, and 2 can't be true, whilst 3 is true. But 3 must be true, yeah? Because this is at x equals 4/3. And so when x is 2, well, clearly this is the concave upwards bit. And this is the thing, at that point of inflection, on the right-hand side you've got concave upwards, on the left-hand side you've got concave downwards. It's like a critical point between the maximum and the minimum where you're going to get the non-stationary point of inflection. It will happen for all cubics. And so actually this is 3 only, yeah? You can certainly work out, I'm guessing that this doesn't work out right when I plug 4/3 into here, yeah? I haven't actually done it, but just because of the way the answers are, I can see that 2 to 5 is going to be concave upwards, so it must be 3 only. Okay, number 10. Have I got number 10 here? Yeah. What is the gradient of the curve? Normal to the curve y equals x cubed at the point where x is minus 2. Okay, so this is a lot easier. That's what's weird about this paper. It has really nasty questions interspersed with really quite easy ones. Okay, so the gradient of the tangent is going to be minus 2 squared is 4 times 3 is 12, minus 8 minus 2, so the gradient of tangent is 2, so the gradient of the normal is going to be minus a half, and so that one's B. Okay, do pop along to the other channel, which I just showed you, the new channel. Please do subscribe and all that nonsense. Yeah, you'll find the rest of this paper there. Keep up the great work, and hope you enjoyed the video and it's useful. Bye-bye.